In this example, we are going to make a stem and leaf plot. Now these are great plots. They give us an idea about the distribution of our data, but they can be a little tricky to make. The idea with making a stem and leaf plot is we are going to identify the leading values in all of these numbers, and that will become our stem. And then with the other values in the number, those will become the leaves. Alright, so let's see how this works out by first creating the stems. So I look at all the numbers in my leading values, and it looks like I have a 2, a 5, some 6s, 7s, and 8s. So it looks like my data goes between the 20s all the way up to 80s. So I'm going to use 2, 3, 4, 5, 6, 7, 8. And these are my stem. I'm going to put a big vertical line to separate these out from the leaves. Here's where I start to collect all the other numbers. So if I have a 23, let's put the 3 there. When I get to this 3, well, I don't have any 30s, so I'm going to leave that one blank. No 40s, leave the 40 blank. Here's a 58, so let's go ahead and put an 8 next to that 5. And now we get into these 60s, and we got lots of 60s. In fact, I have 2 62s, so I'm going to put a 2, and then I'm going to put another 2. So the way I read this is, here's one 62, and here's another 62. Let's keep going. So it looks like I also have a 63, a 65, and a 67. So 3, 5, and 7. All of these are my 60s. Alright, we're on a roll. So let's finish off these 70s. I got a 71, 71, and a 72. So 1, 1, and 2. And looks like I have some 80s. An 80, 82, 82, 82. Now, with the 80, make sure you go ahead and you put in a 0. You don't want to leave it blank, because the blank means that you don't have any of those particular data points. But we do have an 80, so put the 0. Then a couple of 82s. Oh, looks like another 82. 1, 2, 3 of them. So again, these numbers represent the leaves. So the way we read this is we recognize that this is our leading term, so 5, and there's our trailing term, so this would be a 58. That number would be a 65. And we can see that many of our numbers are in, say, the 60s and 70s. So again, it gives us a great idea about the distribution of our numbers.
These look the same as the stem plots that we looked at in an earlier tute, only they have leaves going out either side from a central set of stems, and it looks like this. This is one that appeared on the 2006 Exam 1, so the multiple choice, and there were 3 questions that related to this back-to-back stem plot. One was to do with whether they're categorical or numerical data, another one was to do with finding the range, and another one was to do with describing the shape. So what we've generally looked at is stem plots that are just this side of it. They have a stem here, and then they have leaves coming out that way. When you put 2 stem plots back to back like this, it works the same way. They share the same set of stems, and they just have different leaves either side. So you would use this when you're comparing some numerical data to 2 categorical pieces of data. So for example, if you had gender and you were looking at heights of male and female, then these are 2 categories, and then you've got some numerical data. So that's another thing you might present on a back-to-back stem plot. So you have 2 categories and you've measured something within each of those 2 categories. That's when you'd use a back-to-back stem plot. So the thing to watch out for is that in the stem plots we're used to seeing that come out to the right here, you have the lowest number closest to the stem, and the numbers continue on outwards going from left to right. So for example, here we have 3, 3, 4, 5, 5, 6, they're continuing going out that way. On the left hand side, when you have stems in the center and leaves coming off this way, it works the opposite way in a sense, because we put the lowest number closest to the stem, closest to this bar, and the numbers count away. So the lowest number is here, closest to the stem. The next lowest number is here, and they get higher and higher as you progress out from right to left. So that's something to watch out for. This one here is also using split stems. And all that means is that rather than having, for example, on this line, the line that starts with a stem of 2, there's a lot of numbers coming out either side. So rather than just having 1, 2 and putting all of those numbers going all the way out to the left or all the way out to the right, they split each stem up into 2 groups. So this is the lower 2s and this is the higher 2s. So anything that's a 0, a 1, a 2, a 3 or a 4 would come next to this lower stem, and then anything that's a 5, 6, 7, 8 or 9 would come next to the higher stem. And if you're using split stems, you have to use it all the way down for all your stems. You can't just split up the 2s and then have 3, 4, 5, for example. Now their lowest stem here is a higher stem of 1 because this is 5 and up. So they would have another 1 down here, except there's no leaves next to it because there's nothing that falls 0 to 4 as leaves on either side here. So they've got a higher 1, a lower 2, a higher 2, a lower 3, a higher 3, a lower 4, a higher 4. And those are their split stems. Working with back-to-back stem plots is very similar to just one-sided stem plots, so long as you remember that the numbers on this left side are counting from the bar and moving away. So if we were asked to find the range of this side, of just the beach side, this would be the highest number, which is a 38, and this here would be the lowest number, which is a 15. So to find the range, you would say 38 minus 15. You find the median on a back-to-back stem plot in the same way. You just find the median for each side separately. So 1 from the bottom, 1 from the top, 1 from the bottom, 1 from the top, this is the next highest number. 1 from the bottom, 1 from the top, 1 from the bottom, 1 from the top, this is the next highest number. 1 from the bottom, 1 from the top, 1, 2, 3, 1, 2, 3, 1 from the bottom, 1 from the top, 1 from the bottom, 1 from the top. This here is the median. Same as doing it over on this side, you just have to be careful of which is the lowest number and which is the highest number. So over here, this is the lowest number, we're going left to right, is low numbers to high numbers. And over here, we're going inwards, this is highest numbers on the edge. So this is 1 from the bottom, 1 from the top, bottom, top, bottom, top. This is the next highest number here. Bottom, top, 1, 2, 3, 1, 2, 3. This is the next highest number. 1, 2, 1, 2, 1, 2. That would be your median. And describing shape works very similarly as with normal box plots. So for example, this one on the edge, here we've got something that looks roughly symmetrical around about this peak. It's balanced going down either side, but you've got a couple of outliers sticking out here. So this side is symmetrical with outliers. This side, it's not as clear, but if I put my pen on the top of this peak here, I probably want to roll down the hill that way. So it's got a slight positive skew to it because my pen is pointing towards positive numbers. And there are no obvious outliers on that one.